decontamination and the construction industry, which is not an obvious topic, but we'll give it a go. So yeah, my first thoughts when I was asked to speak were kind of, really? I mean, they're not the most obvious of combinations, so I thought it was going to be, am I in the wrong place? No, I'm meant to be here, I promise. And yes, I know. But construction and the decon industry aren't the most obvious bedfellows, perhaps more obvious than these guys, but yeah, I sat down and thought about how we'd look at things and the overlap, and it's quite surprising. So if I give a very quick run through of how, why and where we actually work, and then look at some of the applications and then go from there. So how? Well, yeah, there's a range of different fumigants, or at least there was a range of different fumigants. Over the last kind of 18 months, there's been a huge raft of legislation within the EU. So obviously I'm voting in, it's around the health and safety and also the efficacy. So as a result of the legislation, with pretty much the gold standard is the use of hydrogen peroxide vapor. HPV, VHP, they're used interchangeably. So in terms of how it works, we seal the facility. And literally we just use tape. Within other fumigants or technologies, there's a requirement to have it sealed hermetically, and then leak testing and then pressure tests. And with peroxide that isn't the case. So literally tape is more than sufficient to seal the area. And then we introduce the vapor. This can be from outside the area, from inside the area. We can do both, and then ultimately we let it do its stuff. So basically, within a sealed space, we'll bring in the vapor, and that will then cover every surface within the area, and it kills everything from Ebola to anthrax to pretty much everything. But we'll touch on that in just a second. And once we're happy that we've got the qualified level of decontamination, then basically we remove it. So it breaks down to oxygen and water vapor, and so there's no residues, no smells. Once we're finished, it's safe for the next patient or animals or whoever straight back in. And the whys. So basically it's to kill germs. Basically, the applications are either to remove contamination. So if there is a risk within an area, be it Ebola or MRSA within a healthcare setting, or more specifically towards a building project, aspergillus or kind of molds, or looking for a classified facility, either the decommissioning of a clean room or a biotech plant or animal plant, or at the end of life decommissioning. So it can be used to remove a known or suspected contamination from an area. But also it's to prevent contamination. So either of items going into a clean room, they can be placed into a pass-through chamber and then exposed to the process, and then drawn into a clean room, or also leaving a controlled area. It can be placed into a pass-through and then deconned, and then it's then safe for use. So yeah, I mean, for example, when this went wrong in the UK about 5 years ago, there was the foot and mouth epidemic, and so there was bin piles of Afghan cows. So the removal and control of contamination is a really kind of important thing. And finally, going back to the ways. Well, obviously hospitals and clinics. There's the huge increase now with hospital-acquired infections. So clean rooms, laboratories, and then a huge one for Ireland. It's not working. Is biotech facilities. I mean, I'm based in the UK, but I can think of kind of 4 or 5 huge biotech projects within Ireland that are either currently being built or could be commissioned. There's a huge influx of new builds, and obviously the biotech processing is at risk massively with viral contamination. There's a huge overlap there. And then going to food production, and then also biomedical facilities. So animal areas, and then finally medical device manufacturers. And basically, if you pay us, we will come. I mean, we've done schools, vehicles, anything in between, but this is our kind of bread and butter. Again, this is very quick, so I'll fly through. So again, why are we here? It's quite profound, but basically, there's an element of decon now which is increasing hugely within the construction industry. And it can either be within the main tender or as a client, a requirement for either a fixed or a mobile system. So basically you buy the vapor generator, and that can either be built into the fabric of the building, or a unit that can be taken from room to room to room. I also have a service deployment. So you've got your nice spangly building. When you want to move in, get rid of any buyer burden, you can come in. We can treat the entire area. So you start from a baseline of 0 buyer burden. So, and these ultimately will be the client choice. So whether you go for fixed or mobile, or for the service option, each one requires some input from other builders. So there's infrastructure that is required for it to be effective. And also future-proofing. If you've got a huge area, be it for production or pharmaceutical use, if there is an issue in the future and they need contamination, then if the area has been set up in such a way that it's what it's called econ-friendly, which is a bit cheesy, but basically it just means that we can come in and make a certain area, so we can, if there's an issue in room 6, we can come in with room 6 and then go over for TM metals. If it's an open structure or it hasn't been thought about at the design phase, then it can shut down the entire building, and that's a huge costly intervention. So yeah, econ-friendly. It's obviously a bioqualter, but basically, at a very basic level, it means that everything in the area is suitable for decontamination. So the finishes and the fittings are all peroxide friendly. But kind of more than that, yeah, I mean, we've got a huge raft of testing. We've got a very active R&D department and they test all the new finishes, new equipment, and that then feeds a regulatory approval, so the EPA, and that's now coming within Europe, as mentioned briefly. But also we've got published peer-reviewed papers from Johns Hopkins in the US, Yale University. I mean, we've been there for approaching 10 years. There's our guys based on their sites, going from room to room within a hospital to deal with healthcare acquired infections, and brutally, if it didn't work, then we wouldn't be there. So, and tying into that, this is a screenshot from Tata Steel, one of the world's biggest steel makers. I mean, this is a company that can buy and sell us with their petty cash tin, and they advertise that they are bioqual approved, which is a bit hilarious. But you can see how the market's changing in the. Peroxide is now being considered by builders as a necessity and a part of the setup. And again, involving bioqual in the design phase. I mean, we work in a range of facilities: the good, the bad, the ugly, across a range of sectors. So we've got a raft of experience that we can bring. Across the industries. And HVAC consultancy, obviously it's a huge impact on what we do. You know, it's designed to move large volumes of air, so we can also move large volumes of contaminants. So just involved early, we can help with the process flow. We aren't M&E engineers, we don't claim to be, but we can take our expertise to actually tie in with the M&E guys. And also advise on the specifications and the materials, not just on what's suitable for a peroxide, but also what you need. With other fumigants, you need a hermetically sealed, basically a nuclear bunker to actually run the process It's got to be sealed. It's got to be lined concrete, which is obviously very expensive. For a peroxide, you can have a plasterboard tunnel decked out in a vinyl with interlock doors. It's a much cheaper alternative, but by being involved in the design phase, we're able to say, guys, you don't need this. It can be that. So it makes for a more effective build, and also saves money and effort brutally. So again, I'll speed in through this to try and catch up. So in terms of fixed or mobile service, ultimately it's a client a decision, but whether they go for fixed, mobile or a service application, there is some infrastructure that is required from the builder. So looking at a fixed system, in the design phase, you've obviously got the architects and the builder, but involving BioQual too will actually help to streamline the design. Likewise for the integration, it will also require the BMS guys. Likewise for the installation. For a mobile system, again on the design phase is the architects, builders, and then BioQual, and then the integration, because we're mobile, the builders aren't required. And again, in the installation on how the unit communicates with the built-in's BMS, and this sounds strange in that even for a service, involving BioQual at the design phase and make it econ friendly, and so we can isolate single areas, which can, especially for the likes of the bigger biotech guys, where if there's like a viral contamination within an open process, it can cause huge damage to the entire line. So being able to really segregate and compartmentalize different areas can be a kind of a huge impact. I put a question mark here with the BMS guys, because we can also fumigate the ventilation systems too. But again, with some careful planning with the M&E guys, we can actually isolate the HVAC too. So we can do individual sections. The whole thing get around being able to have a usable building whilst it's undergoing the decon process. So that was a whistle-stop tour, shall we say. But in summary, basically, early involvement with the clients and the architects and the constructors leads to basically saving time, thinking about the angles for decontamination as to where it's going, can save time, save money, and more importantly, deliver a more efficient facility for the client. Hopefully that wasn't, thanks for listening, and if there's any questions, hopefully that covered most things, but it's alright.